So, how do you find the limit? We plug in numbers. If I was to ask, find the limit as x approaches 5, I suggest you use, for x, 5.01 and 5.0001, 4.99 and 4.9999. Some numbers above, some numbers below, and that's pretty much it. No need to plug in a whole bunch of numbers. And if the y value is leveling off, if you notice those are the same, then you're in good shape. If not, you have to plug in a bit more. Now, algebraically is how we're going to play with a limit. A limit exists if the limit from the left and the limit from the right are equal. For example, a limit exists if I plug in numbers. We chose -2, we chose -2.01, those three values below, right? And we chose above those values, and we got them not to agree. We said the limit doesn't exist. That's how a limit exists. So a limit exists if the left and the right are equal. If the left isn't equal the right, the limit does not exist. So if the limit as x approaches a number from the left equal this number, if the limit as x approaches the number from the right of f of x is equal to the same number, we say the limit exists. Otherwise we say the limit does not exist. Now, limit of a constant. If I have y equals c, here's y equals c. Do you notice graphically, no matter what a approaches, you're gonna always be at c? So limit of a constant is the constant. Besides that, we have a shortcut. So this is what we're doing. How do you find the limit? You plug in numbers. Numbers above and numbers below. What we're doing right now is a shortcut. Rule of thumb we call it. If you take in the limit as x approaches a number of a function that's a polynomial, rational were defined, radical were defined, log were defined, exponential were defined, we plug the number in. If you get a value, you're done. If you get a number over 0, we say does not exist. And if you get 0 over 0, which is the majority of the time, we simplify. And that's why we went over A3, A4, A5, and some of the algebra initially. An exception to the rule is absolute value. Absolute value doesn't satisfy this shortcut. The shortcut works only on these types of functions. So when they say find the limit, this is a constant. Limit of the constant is the constant. Done. That simple. This is a shortcut. You could plug in numbers, but there's no point. Number 18. If I want to take a limit, do you see what this says? If you see a polynomial, a rational, which is the majority of what we see, take this value and plug it in. If you get a number, you're done. If you get a number over 0, does not exist. And if you get 0 over 0, you have to simplify. So if I substitute for x a 3, that's 3 cubed. Isn't that a number? I'm done. That's the limit. If you were to pick points above 3 and below 3, guess what? You will get 27. Shortcut. Nice shortcut. How about here? Well, that's a polynomial. Substitute the -4 in. Isn't that 4 times -4 plus 3? -16 plus 3 is -13. Done. So it's that simple how we're going to play with this. How about here? This is a radical. Throw the 5 in. Wouldn't that be the cube root of 5 minus 5? Cube root of 0. Isn't the cube root of 0, 0? How about 34? So this homework runs really smoothly. How about 34? Throw a -8 in there and there. So that is 3 times -8 divided by -8 plus 2. Wouldn't that be -24 over -6? Isn't that a positive 4? What if I attempted number 42? What if I substituted a negative 3 right there and right there? Wouldn't that be negative 27 plus 27? Over negative 3 plus 3? Isn't that 0 over 0? What happens if you get 0 over 0? If you get 0 over 0, you simplify. Well, there are 4 kinds of simplifications. First kind, you factor. We did that already. If you factor, this is the difference of cubes. That is x plus 3. Square the first, multiply those, the last squared, positive. This sign is always the opposite of that. Do you see that those cancel out? Once something cancels out, you restart the whole process, meaning you throw the negative 3 in again. Negative 3 squared minus 3 times negative 3 plus 9. That is 9 plus 9 plus 9. That's simply 27. That would be that limit. How about the second type, a radical equation? I throw a 3 in. I throw the 3 in there and there, and I notice that that's 3 plus 1, that's square root of 4 minus 2, over 3 minus 3, that's 2 minus 2, that's 0 over 0. Well, anytime there's a 0 over 0, I need to simplify. How do you simplify a radical? There's one way of proceeding. You multiply by the conjugate. Remember the conjugate? What's the conjugate to this radical? The same exact thing, except the opposite of that sign. They're always opposites. Now, the denominator you never multiply out. So, whatever you're rationalizing the radical, the non-radical part you leave alone. And if you multiply those, you'll get the first squared minus the second squared. The first squared is x plus 1 minus the second squared. 2 squared is a 4. That's the limit as x approaches 3. X plus 1 minus 4 is x minus 3. And do you notice what happened? This happens every time. Once you cancel a value out, you substitute, you restart the whole process of the shortcut. You throw a 3 in there, that will be 1 over the square root of 3 plus 1 plus 2. That is the square, that is 1 over, that's a 2 plus 2, that's 1/4. Done. Now, do we know what this says? This says, find the limit as x approaches negative 1 from the right. So, negative 1 from the right, negative 1 from the right. Wouldn't you say like a negative 0.99 and negative 0.999? And if I throw my calculator out and take 6 divided by parentheses answer plus 1, and now if I go in and put in the answer negative 0.99, this negative, remember, 600. What if I put negative 0.999? Negative 0.999. 6,000. Can you guess what's happening? I'm going to say this limit is going to approach infinity, because obviously if I go by a negative 0.9999, my guess it's going to be 60,000. This thing is growing without bound. Right? It's a single-sided limit. You don't have to do both, only one side. How about here? Here they want us to take the limit as x approaches 0 from the left. So when I make my table, x and x plus 1 over x. From the left, I'm going to take negative 0.1 and negative 0.001, right? If I see a big number or a small number, I'll have a good idea. In this case, I'm going to input this in my calculator, answer plus 1 over answer. Parentheses, answer plus 1 divided by answer. And I'm going to go in and put in the negative 0.1. Negative 0.1, enter. I'm getting negative 9. That doesn't tell me much. How about if I inputted this in my calculator? How about negative 0.001? Enter. Go back and evaluate. Negative 999. Wouldn't you say this is approaching negative infinity? So one-sided, use a calculator. Two-sided, you say, okay, well, how about this one? X approaches negative 1. Put a negative 1 in there. 2 times negative 1, so that's 2 plus 1 minus 3 over negative 1 plus 1. Isn't that 0 over 0? I am going to simplify this. How do you simplify this? You factor it. Why did I put number? Okay, that's kind of odd. 2x and an x and a minus 3 and a plus 1 over x plus 1. And those cancel out. 38. That's probably my mistake. Once you cancel something out, what do? You plug in the negative 1 in. That becomes 2 times negative 2 minus 3 is a negative 5. Now do remember that you need to use your calculator. And I'm giving you 13, 70, all of these numbers right there. I want you to find the limit. Ignore directions, just find the limit on number 77. So those follow directions. On number 77, part C, ignore directions, just find the limit.